I'm speaking to you about artificial general intelligence, AGI. Not just another tool, but potentially the first non-human mind to match or exceed our cognitive capabilities across every domain that matters. A technology that could fundamentally transform what it means to be human. This is not science fiction anymore. This is not some distant future concern. This is happening now in research labs around the world, in the algorithms that increasingly shape your daily life. And you, yes, you watching this, are living through what may be the most pivotal moment in human history since the development of language or agriculture. Think about what makes humans special. Our ability to reason abstractly, to learn from a few examples, to generalize knowledge across domains, to plan for the future, to understand ourselves and others, to create art that moves us, to build civilizations. Now imagine all of that capability, and more, embodied not in flesh and neurons but in silicon and code. Before we can understand artificial general intelligence, we must first grapple with a more fundamental question: what is intelligence itself? Intelligence has proven notoriously difficult to define. We recognize it when we see it, yet struggle to capture its essence in words. Is it problem-solving ability? Adaptation to environment? The capacity to learn? Or honestly, is it something more ineffable? For centuries, philosophers and scientists have proposed different definitions, each capturing some aspect of this complex phenomenon. Aristotle saw it as the faculty of thought. Darwin understood it as adaptive behavior. Modern psychologists measure it through standardized tests. But intelligence isn't a single thing, it's a constellation of capabilities. Analytical intelligence helps us solve logical problems. Creative intelligence generates novel ideas. Emotional intelligence navigates social relationships. Practical intelligence applies knowledge to real-world situations. These capabilities emerge from distinct but interconnected systems in our brains. There's no single intelligence center, rather, it's a complex interplay of perception, memory, reasoning, and more. Our attempts to measure intelligence have often been, well, kind of reductive. The intelligence quotient, or IQ test, developed in the early 20th century, primarily captures analytical and verbal abilities. It predicts academic success reasonably well, but honestly, it misses crucial dimensions of human capability. Someone with an average IQ might possess extraordinary creativity, emotional depth, or practical wisdom. Intelligence is multidimensional, and our measurements are incomplete at best. Moreover, intelligence isn't uniquely human. Crows fashion tools and solve multi-step puzzles. Octopuses navigate mazes and open jars. Dolphins recognize themselves in mirrors and communicate with complex vocalizations. Each species has evolved intelligence suited to its ecological niche. What makes human intelligence distinctive is its generality. We excel not at any single cognitive task, but at learning and adapting across an enormous range of domains. A human child can learn any language, master countless skills, and navigate novel social situations, all with the same brain. This generality allows us to transfer knowledge between domains. A principle learned in one context can be applied to another. A metaphor from one field can illuminate another. This cross-domain flexibility is really the hallmark of human intelligence. And this brings us to artificial intelligence. Most AI systems today possess narrow intelligence. They excel at specific tasks but fail completely outside their domain. A chess program can defeat grandmasters but can't recognize a cat. An image classifier can identify thousands of objects but can't hold a conversation. Artificial general intelligence, by contrast, would possess the same flexibility and generality that characterizes human cognition. It would be able to learn and perform any intellectual task that a human can. It would transfer knowledge between domains, adapt to novel situations, and potentially improve itself. More specifically, AGI would need to demonstrate several key capabilities. First, reasoning. That's the ability to draw logical conclusions, understand cause and effect, and solve novel problems. Second, learning, not just pattern recognition from massive datasets, but the ability to learn efficiently from limited examples, as humans do. Third, common sense, the vast background knowledge about how the world works that humans just take for granted. Fourth, planning. That's the ability to set goals and devise strategies to achieve them across multiple timescales. Fifth, communication. Understanding and generating natural language with all its nuance, ambiguity, and cultural context. And finally, self-awareness. Some degree of understanding of its own capabilities, limitations, and place in the world. How would we know when we've created AGI? Various tests have been proposed. The Turing test, conceived by Alan Turing in 1950, suggests that if a machine can fool human judges into believing it's human through conversation alone, it should be considered intelligent. But the Turing test has limitations. Modern language models can sometimes fool people briefly, yet clearly lack understanding of what they're saying. They're sophisticated pattern matchers, not truly intelligent systems. More rigorous tests have been proposed. The coffee test requires an AI to enter an unfamiliar house and figure out how to make coffee. The college student test requires it to enroll in a university and earn a degree. The employment test requires it to learn and perform an economically valuable job. So, different researchers actually define AGI in different ways, and these definitions have really important implications. OpenAI, for instance, defines it as AI systems that outperform humans at most economically valuable work, which is a definition that's really rooted in practical impact. On the other hand, DeepMind's Demis Hassabis focuses more on scientific discovery, suggesting that AGI would be able to make breakthroughs in mathematics or physics. The definition we choose actually matters a lot because it shapes what we build and how we evaluate it. If we define AGI purely in economic terms, we might create systems that maximize productivity but lack a deeper understanding. But if we define it in terms of scientific discovery, we might end up with brilliant problem solvers that, lack social intelligence. The gap between current AI and true AGI honestly remains pretty substantial. Today's most advanced systems excel in narrow domains, but they just lack the flexibility, common sense, and generality that really define human intelligence. Sure, they can recognize patterns in data, but they seriously struggle with things like causality, counterfactuals, and abstract reasoning. A human child, for example, can learn a new concept from just a few examples. They can reason about hypothetical situations they've never experienced, and they can understand the physical world, social dynamics, and even their own mental states. Current AI systems, they fall short on all these dimensions. Some researchers actually have proposed more nuanced frameworks for measuring machine intelligence. For instance, the collective intelligence test evaluates systems on their ability to collaborate with humans. The catastrophic forgetting test looks at whether systems can learn new skills without losing old ones. And then there's the generalization test, which assesses performance on tasks that are significantly different from the training data. It's worth noting that AGI doesn't necessarily need to replicate human intelligence exactly. Just as airplanes don't fly like birds but still achieve the same function, AGI might use different mechanisms than the human brain while achieving similar or even greater capabilities. The goal isn't to duplicate human cognition, but rather to create systems with comparable generality and flexibility. Human intelligence is also, deeply embodied and emotional. Our thinking is shaped by our physical experiences, our emotions, and our social connections. Whether AGI would need similar embodiment and emotional capacity, that still remains an open question. So when I talk about AGI throughout our journey together, I'm referring to artificial systems that can perform any intellectual task that humans can, with comparable or even greater proficiency. Systems that can learn, reason, plan, and communicate across domains, systems that in some meaningful sense understand the world and their place in it.